Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. So this is about me. I am a computer science gate faculty having more than 5 plus of teaching experience, mentored more than 50,000 students, taught in different coaching institute all over India. Okay, it's like the Gate Academy, even qualified multiple times Gate, and even I have given the coaching in many government colleges as well as in many private colleges. Like in SRM Chennai, I have given coaching. CAT Bhubaneswar, I have given. BC Bhagalpur, Jorhat College of Engineering, Guwahati University, Dibrugarh University, Government College of Engineering and Technology, Jammu, Ramgarh Engineering College. Okay, these are the colleges where I have went and I have given the coaching. Now we are going to see relational and logical operator. Relational and logical operator we are going to see. Only some part is remaining. Relational and logical operators. Okay. So we are having a relational operators that sometimes we call it also as a comparational operators. Okay, that we compare. So, so the relational operators are the relational operators are greater than equal to smaller than equal to. Okay. So this is a relational operator. So they have the same precedence. All this is having they have the same precedence. Same precedence. All this is having a same precedence. Same precedence. Okay. So whenever any two operator will have same precedence, we go to the associativity. Means whether two evaluate from left to right or right to left. Okay. So whenever it is having a same precedence, go to the associativity. So its associativity is also from left to right. Okay. So it is just below to the equity operator. So it is just mm, below in the. So after that, its below is equity equality operator. Is having equality so which is having plus equal, and next one is not equal. So generally it is like this, it is like not equal. Okay, it's like not equal. It is to check whether two expression is equal or not, and it is to check whether two expression is not equal. Okay. So today we will see till relational only because I am feeling very much tired. Now see logical operator. So we have seen these relational operators which is having the same precedence, and associativity is left to right. Associativity is left to right. What happened? Now see the logical operators. So logical or, so it's logical and double logical and last one is your logical or. Okay. So expression connected by this, it is very important that short circuit you will use in logical operation. Short circuit. So expression connected expression connected by and or this or are evaluated left to right, are evaluated left to right. It is going to evaluate from left to right, left to right, and evolution is stop, and evolution is stop, and evolution stops as soon as the truth, as soon as the truth or false or falsehood of the result is known. The result is known. I will explain that. Okay. So please write it. I will explain that. It's what I mean here. This is the short circuit. Short circuit. Okay. So you know that this is having the that logical and is having a higher precedence. It is having a higher precedence than logical or. So expression connected by logical and logical or are evaluated left to right. It is going to evaluate left to right, and evaluation stop as soon as the truth or falsehood of the result is known. So I have made a table to explain this is. So just that short circuit. Okay, let it be. So see, the short circuit in C, because of short circuit, that is called as short circuit in C. So if you are having some expression like A expression 1 and expression 2 and expression 3 is there. Okay, you are doing and. So if it is false, then you will go there, you will check. Is it false? Then you will again go there, false. It will reveal. So output is false. One thing is wrong. If it is false, then no need to go because it's false now. If it is false, if one is false, no need to go in there. So you are not executing expression 2 and expression 3. It is going to false. See, it's saying that because and is there now. For and to satisfy this condition, all these statements should be true. All these statements should be true. Now if this is true, then you will check this one. If it is false, then no need to go. This is the result. This is the result of the expression, final result. It is false. Now if it is true, and if it is true, then you will execute this expression 3, and if it is false, then it's false. Now if it is true, and if it is true, and if it is also true, then only it is true. That is short circuit. So that here it is saying that expression connected by and or are evaluated from left to right. It is going to evaluate from left to right only, and evaluation is stop as soon as the truth or falsehood of the result is known. As soon as we will stop when we know the truth or false according to that. Here since it is and, so till the time when we are getting true, we will go to the next. When we are getting true, we will go to next. But whenever we get false, we will stop. False, stop. False, stop. False, stop. So same way, if you are having a or, if you are having a or in or, so expression 1 or expression 2 or expression 3, like this. Now if this is true, now if this is true, no need to execute this two. Why? Because any one of it is true, our answer is true, because it's or. Okay. Now if it is false, then I will go there. If it is true, answer is true. If it is false, and if it is again false, and if it is true, then our answer is true. And if it is false, and if it is also false, and if it is also false, then our answer is false. Am I clear? Because it's or any one of these. So we will execute from left to right. So if it is true, true. If it is false, then execute the second expression. It is true. No need to execute third expression. Our resultant is true. Okay, in this way. So if I will give an example, if A is equal to B, sorry, A is equal to 2. It's a assignment expression. Expression can have assignment also. 2 or here I am having int A B equal to 5. Okay. Now here I am doing B equal to 6. Okay. So this I have done. Now I am printing printf percentage D, new line, then percentage D. Okay. A and B. A and B I am printing. Okay, so first you will have B. You let's assume you are having A also here. Declare A also. Now what is going to be the output? So first B is equal to 5. Okay, fine. So B you are getting is equal to 5. Now it is a OR, so it will execute from left to right. Yeah, A is equal to 2. It will assign 2 to A. Yeah, it will assign. Now see, this is an assignment operation, and this expression value is going to 2. This expression value is going to, whatever will be the value on the left operand is going to be true. So it is going to be true, so it will not execute. It is going to be true, so it will not execute this. So you can try this one in your home. It will be true. Now it will go there and will print A. So A is going to your 2 and B is going to your 5, because this is not happened. This is not happened. So 2 and 5 like this, because new line I have given. That I want to explain. Okay, is it clear? Now similarly, if I make here and, now if I make here and, in this only I am just changing. Example, int b equal to, if I make b equal to, if I make b equal to 5 and a. So if a if a is equal to 2, here I am doing assignment, not condition checking. I am not checking a equal to 2. I am doing assignment. In a I am just putting 2, and I am saying b equal to 6. Both assignment I am doing. Now here I am printing. Now tell me what is going to be the output. Output क्या होगा आप बताइए आप लोग. परसेंटेज डी न्यू लाइन, परसेंटेज डी क्या होगा. Now what is going to be the output? So you will see here, first b is going to have 5. B is going to have 5. Then a is going to have some garbage because it's auto. Okay, now a is equal to 2, you have done. A is equal to 2, you have done. It's true. It's true. But since it's a and operator, but since it's a logical and, so if it is true, then you have to go to the execute the other expression also. You have to check whether this expression is true or not. B equal to 6. So B now overwritten to 6, and it is also true because this expression is having a value 6 and this expression is having a value 2. So non-zero value in if case is treated as true. Non-zero, it's treated as true. So it is true, it is true. True and true is your true. Now it will go here and will give the output A as 2, then new line B as. So this is short circuit in C. Okay. So that's why they have written that whenever logical and logical or is there, we have to go like this. A तो 2 हो गया ना, और B 6 हो गया. And है, देखिए यहाँ पे बताए थे हम. If you are having a and, if you are having a logical and, so if it is true, if it is true, then execute the next. Then if it's then again execute the next. So we are having only two expression. That's why we have executed only two expression and we got true. Everyone please like this session. अच्छा अच्छा means only true. Session को like कर दीजिए. So we have seen relational operation also. Relational भी देख लिए हम लोग, logical operation भी देख लिए. Now we will see. Okay. Now we will see that not operator, that unary. Okay. So you write by definition the by definition. So this is the last topic. So by definition, the the numeric, the numeric value, by definition, the numeric value of a relationship, of a relational or logical logical expression, a logical expression is 1. So by definition, the numeric value of a relational or logical expression is 1. By definition, numeric value of relational or logical operation, if it is true, then it is going to be 1. Okay. If the relation is true. If the relation is true, it is going to give 1. If the relation is true. The relation is true, it is going to give 1, and 0 if the relation is false, and 0 if the relation and 0 if the relation is false. Okay, and 0 if the relation is